What's up, guys? Chris with Craft CNC and CNC for Newbies here. Wanted to go into uh, doing the Jesus carve. As you guys saw, this was the Mary carve. This is Vitaly's model from 3D Wave. Well, this is specific to me, but he's the modeler behind 3D Wave and a couple of the other really big modeling websites. So I'm getting ready to carve the Jesus statue, and that's going to be a little bit taller, a little bit bigger. I do that one at 3¼ inches in diameter, and it's roughly going to be about 12 inches long. And we'll work on that. But what I wanted to show you guys was finish setting up the rotary to actually get these things to carve. And I'm going to kind of go through and explain how I set up UCCNC and my my chuck and my tailstock to get a good carve. Okay, so let's flip the camera around here. Settings, camera back. Okay. All right, and I can see comments. Good. Okay, so first thing we need to talk about is the rotary setup and the probing functions. Okay, you can probe in UCCNC. You can probe the rotary just like you would a generic 3, 4, 5 axis setup. You know, this is just a simple 4th axis. It just happens to be a rotary instead of a linear. Okay. So the very first thing that I do is whenever I set my rough measurements up, I use this level. And I had it against my bump stop here, and that set my off for me. Okay. So I put my rotary axis on, I push it against the level that's against the bump stop. That sets parallelism to a point. Then I have to fine tune it. The way that I tune it is I actually use this 1/4 inch precision ground metal dowel rod, and I'll actually just come over and I'll run it along this back surface. The reason why I run it along this back surface is because I want to make sure that I have clearance for this plate and this plate. I have crashed those into this, the chuck and the teeth, and it's not fun. You know, live and learn. But so and I know that this is this measurement here. So that gives me my center line. And as you can see, I have my center line marked. That's actually scribed in real faintly. But I take this dowel and I touch it to the aluminum surface. It creates a close in the loop, and the probe is active right here on UCCNC. So I find one point and I find where it's active and I zero. You don't have to zero, you can write it down. I just find it's easier to zero the DRO. So I zero it, I back off 1/4 inch, and I come to the other end. I move in slowly. I go up to about an 1/8 inch step. Then I drop it down to tenths. Um, and I basically creep in on it till it says active if it's too far that way. If I come to my 0 point and it's still not active, I know that the chuck area needs to go that way until it comes and touches this point. Okay? So there's a little bit of math involved and there's a little bit of understanding involved that if you're touching on one end and you're not touching on the other end, then it needs to go that way. If you're touching on this end, you bring it up here, and you're not able to get to your zero before you're touching, it needs to come this way. So that sets this parallel. That's parallel to the center line of the chuck. Okay. Um, then once I have that, I know what my center line measurement is. It's basically half of this block. So I take calipers and I measure the block surface. Um, Let me see if I can do it one-handed. All right. And now I can divide that by 2, and that gets me my center line. But you have to take into account an extra 1/8 of an inch because this dowel is a 1/4 inch. So it's whatever this 0 is plus half of the total measurement plus of the tool. And that will put the center of your spindle over the center line of the rotary axis. So now you found your center line going all the way down the x-axis, parallel to the x-axis. All right. Once you do that, you then have to come down and repeat those processes for the tailstock. You put the level on there, you get a rough um, and basically touch one point and then come back and touch the other point, but you're basing it off of the center line this time. Okay, so I know my center line as 0 because whenever I got my center line up here, I mark the 0, I reset the DRO to 0, and then I come down here. I know what half of this is. I give it an extra 1/8 inch and make up on it. My probe comes up, touches. I'm not quite at 0. I use my little brass hammer and I tap it over until I'm able to get 0. And then I just give it a little tap back that way till it touches 0. Once it touches this pin and is active, we're good. I move back to this. I repeat. I lightly tighten down. I repeat this 2 times and I'm good. Then I have a 0 mark because I do not have a homing switch on this rotary axis right now. I need to put a proximity sensor on it, and I just haven't done it. I have my center line mark, and then I have a mark on my chuck. Those are my 0 marks. What I do is I line those up, and then I re-zero my A axis down here in UCCNC. Okay, so it's 0. I put my material in and I find the highest ridge. When I find that high ridge, I have a beat up V-bit that I use as a pointer, and I line that up with the center line. So I have this in the center line, and then I line up this ridge with that point. I clamp everything down. I go back and forth, make sure that it's good. I make sure that that's the high point. And now I can actually find the highest point on this block of wood. So I know what my offset is from my center line height. Okay. So now I can set everything up in Aspire or FreeCAD or whatever to actually surface off the corners and start getting the round shape that I need. Okay. One of the things I went ahead and did was I took time to use my V-bit and I probed it to the top of the tailstock right here. And then I zeroed that. Once I zeroed it, I brought it over to the point of the tailstock and I brought my point of my V-bit right down so that both of them are touching. And I documented what that offset is. That offset is 1.125 on mine. So from this top surface to the center line is 1.125 offset. Okay. So now I can actually measure all my tools off of this surface with my probe and then just apply a 1.125 offset, and I'll get my tool centered. So now my tool will be centered parallel to X. I'll have my Z0 height, and then Y will actually rotate at that point. And that's basically it. At that point, you can start running your rotary rounding gadget in Aspire and take this square block and turn it to a round block. Once you get it into a round block or close enough to a round that you're happy with it, you can go ahead and start playing around, and just go from there. So in my case, I know that my total height right now, let's see, I am 1.283 inches up. So I got to add the 1.125 to that, and that will give me my total distance up. I'll put that into Aspire for the radius of my material right now. And that will give me a good offset to start circling around this log to square it off. And to square it off, let's see here, I'll use my nice stubby 4-flute Sky 1 CNC bit, or 3-flute Sky 1 CNC bit. And I'll hog this out real quick, get it into a round. Once I'm pretty happy with that, I'll take a diameter measurement. Once I have my diameter measurement squared away, I will go ahead, put that diameter into the Aspire file and my length into the Aspire file, and I'll be good to go. And I can basically start running my toolpaths for the actual part. So there's a little bit that goes into setting up and tearing down a row axis. A much better option is to have the spoil board cut, movable, and drop down like I had before, and then have these on a platform that is pretty much centrally located all the time. It also allows you to do much larger pieces, and go from there. So with that being said, I'm going to let you guys go. I just wanted to go live and show you the rest of the setup. I'm going to cut the Jesus statue today, and we'll go from there. Later.